Hello, welcome to AT&T ThreatTraq for February 5th, 2013. This program provides network security highlights, discussion, and countermeasures for cyber threats. Welcome, and joining the program today, we have Matt Keyser, Jim Quazing, and John Hogoboom. I'm Brian Rexroad, and thanks for joining us today. I think what we'd like to do first here is I think we'll turn it over to John here. And John, it looks like there's some yet more opportunities to eavesdrop on systems, maybe a little bit of a twist of embedded software here as well.
Yeah, you know, we're always talking about how different systems are exposed out there on the Internet. We talked about that last week. This is another spin on that. And this is a story that Dan Farmer put out. He's a security guy. He's been around for a long time doing security-type work. And Bruce Schneider also posted kind of a summarized version of his report that he put together. And the topic is IPMI, which is Intelligent Platform Management Interface, I think. And it's a specification by Intel for baseboard management controllers. And these are the controllers that you would have kind of in a chassis for a blade center or, a similar type of blade-type architecture where you have many server blades inside a single chassis, and it allows this device, this card, to manage the hardware inside that chassis and also inspect what's going on in each one of those devices to see what kind of temperature it's running at, performance statistics, and whatnot. Basically has unfettered access to the system memory of the machine, the blade that's in there, as well as access to the input-output function of that blade. So if you're not familiar with the types of vendors out there, there's a lot of different vendors that have similar technologies. They all kind of have a base underlying similarity in the way they work. Some of the more notable ones that a lot of people know are Dell has their iDRAC, which is the integrated Dell remote access card. I have a picture of that here on the bottom right. And HP has their integrated lights out. And IBM is another big one with their Blade Center. They have an integrated management module. And then there's some other vendors here that I mentioned. And I show a couple of pictures of how, these chassis have it's basically a card that inserts, and it's independent from all the servers inside there, but it's for management of the chassis and the servers that are inside that. Some interesting features that they allow is when you log into, they usually connect to a network. Most people will attach them to a management network. Smart people will kind of put them on a sideband, out-of-band type management network so that people can't get to this thing, because if you can get to it, you basically have complete control of the machine, especially if you can hack the password on it. There's a couple of, and some of the things that it allows you access to is like full remote access. They usually have some method of almost like a remote desktop protocol thing where you can, see exactly what's going on the machine, as well as all the other statistical types of information and access to the underlying hardware of everything in the chassis. Some of the things that Dan Farmer's article points out a lot of things. So I recommend reading the whole thing. He has a lot of interesting insights in there. I'm not going to cover them all, but some of the important ones that he mentioned are if one of your baseboard management controllers is compromised, it's usually controlling multiple machines. So access to one gets you access to many machines inside that complex. The BMC has full access to system memory and I/O space, which I mentioned. The activity is invisible to the server side, relatively invisible, unless you have really if you have super user access and some specific intelligence on how to access the baseboard management controller from the blade, but that's pretty tricky. Passwords are frequently unchanged on these devices. They don't really have good password management functionality, and they're also stored in clear text, which is interesting. That's per specification. So the Intel IPMI specification says to store them in clear text on the baseboard management controller. Breaching a BMC, this is some other interesting insight, is that if you're able to breach it and get access to it, it might yield you access to other protected private networks. So it could allow you through VPN, based on however the chassis is configured, to access private networks that you shouldn't be able to access otherwise. And the firmware is often OEM'd, and it's difficult to manage patches. They have to be signed by the vendor, so if you do discover vulnerability, chances that you're going to get a patch turnaround really quick is rare. So one of the quotes from the article that I thought was good is he says, basically it's a perfect spying platform. You can't control it. You can't patch it. It can completely control your computer's hardware and software, and its purpose is remote monitoring. So something to be aware of. So I put, and this is just me off the top of my head, I threw a couple of recommendations together. Don't connect your baseboard management controller interface directly to the internet. That would be a big problem. I'll leave this as an exercise, and I don't recommend that you go seek this information out except for maybe your own purposes to see if your machines are exposed. But if you go to Google, it's relatively simple to find lots of machines that are exposing their baseboard management controller web user interface, usually. There's some other services like Shodan, which can, through SNMP kind of find some other ones that maybe you could access via SSH and whatnot. Change your passwords frequently, apply patches and updates frequently. These are things that you probably don't do because you're not really accessing this thing a lot or rarely, only during emergency needs because maybe you need to recycle or power cycle one of the blades or something like that. And there is no real good patch management usually for these, so they don't have any kind of update process. So you need to keep on top of that. And then lastly, one of the things that we recommend, or I would, is to log and monitor all network activity specifically to and from that baseboard management controller interface. There shouldn't be a lot of traffic happening there, so monitoring it and logging activity would really help illustrate if there's something going on that you're not expecting.
Yeah, normally it should be pretty sparse and very specific activity that would be taking place on there.
Right.
Yeah,
it's an interesting story. You had something there, Jim?
Well, I was just saying, when I was doing, when a big part of my day-to-day job was system administration back a few years ago, I used to take advantage of these, when it was time to patch the servers. You go in through the console interface, through the remote access, just because you didn't want to necessarily be patching over SSH, and you could then lose your connectivity and screw things up. But one of the things that always bugged me even then was, there wasn't any logging from the remote access piece there. I'd like that to be logging back to some central syslog server someplace so that I could at least see when people were accessing it. But that's one of the things that never made it into the spec, apparently.
Yeah, well, actually, I have a similar career background, and we used to use Blade Center, and I'm pretty sure I did integrate syslog. I think they had syslog on Blade Center because we had that turned on to collect logging. But maybe some of the other vendors didn't. And again, it depends on how it's implemented and whatnot. But I hear what you're saying. It's one of those things where it's kind of a backdoor even for administrators to use, and it's not very often used. So keeping an eye on who's accessing it and when, and making sure that only people that should be accessing it are accessing it is a pretty key component. Some of the other insights he had in the story are really more in-depth about how the baseboard management controller connects to the South Bridge on the chassis, and how you might be able to leverage some of the connectivity aspects at a deeper level to further your infiltration into that chassis, relatively speaking. But there's a lot of interesting insights in there that I recommend you read from the article.
So I guess there are a couple of things that kind of come to mind. I think we already mentioned sort of the relationship to embedded software. You pointed out the fact that doing software updates on a platform like this is very difficult. It's not necessarily well supported, and I think that's a fundamental thing that needs to improve across the industry. That is, if there's software anywhere, there needs to be a reasonable update management process associated with it. But I think it's probably is at least as interesting from my point of view here is that we've been kind of focused on the concern, particularly when we talk about virtual machines and access to the hypervisor and how that might create a vulnerability associated with virtual machines. And here we are. This is kind of a similar kind of mechanism that's been built into systems, has been around for some time, and perhaps evolving a little bit, but not significantly over time, and probably not as well paid attention to, at least in the context of what I've been exposed to in talking about security. I think it was a very good insight of Dan Farmer to point this out, and of Bruce Schneider to relay that message, and hence the reason we're bringing it to the table here as well.
All right. Fine. I just wanted to add that it seems like from the article that there was this technology sort of advanced bit by bit. It was originally just a few small functions, and as vendors decided to add more and more, this became more and more of a full-fledged machine. And you're basically sticking another machine on your network with absolutely no idea of what's going on it.
Yeah.
I feel like this happens a lot with embedded devices these days, where you've got something that started off as, we'll add a feature here and there, and then all of a sudden it's got a web interface and it's got all sorts of vulnerabilities.
Absolutely, and we're actually revisiting that whole notion. One of the real growth areas is machine-to-machine communications. These are, they're very simple things. It might be just monitoring the temperature in a thermostat and relaying that information to a central processor. And they start out very, very simple. And as the things get more sophisticated, features creep into it, sophistication creeps into it, more memory is available, more processing power becomes available, better connectivity is available, and next thing you know, you have a security problem on your hands. In fact, it's also sort of showing up in industrial control systems. I think we talked about thermostats and that sort of thing being infected. So. It's a natural thing to happen, and the sooner you draw some attention to it, better chance you have of getting some security capabilities put in place and protect against these types of problems. Very good observation there, Matt. And with that, perhaps we should talk a little bit about other types of updates. I hear Java's been updated again?
Yes, again. So Oracle released a critical patch update on Friday, fixing 50 bugs in Java, which is huge. And it's interesting. It's good that they're working on patching these bugs and that they have so many that they've actually patched. But it also it shows a little bit of a weakness in the platform overall if you have this many bugs. So Oracle released this patch, covers a number of different versions of Java 7 and 6, addresses flaws, 26 of which, of the 50 that were reported, were remotely exploitable and were rated a 10 on the CVSS scale. So 10 is basically the high end, as bad as you can get. So it seems that they had originally planned to patch some of these bugs in an upcoming update, but as Oracle discovered that some of them were being exploited in the wild online and decided to push up the date for the patch to last Friday. Let's see, some of the changes that have come in with the latest patch is that by default, the Java security settings are now set to high, which means that anybody loading a Java applet in the browser will be prompted, do they really want to run this? And this is a good move, in my opinion. A lot of the web exploit kits that we're seeing these days use Java-based vulnerabilities, and if this is one of the vulnerabilities, this is a good means of getting a user to stop this. The problem with that is that the users have to patch. And from what we've seen, it seems like users are either hesitant to patch or just don't know or how to patch. And as a result, there are a lot of very real Java vulnerabilities from older versions that are still viable in the wild. Many people have suggested that it's time to just uninstall Java entirely. Others would recommend that you disable it in the browser. I'm personally of the opinion that if you don't need Java for anything that's critical for what you're doing, especially if you're a home user, I recommend you remove it entirely.
I think I think we would argue that to be the case for any piece of software. That is, if you're not using it, if you don't need it, make sure that you're taking it off the computer. And oftentimes you realize how much you really did need it after you do that. But I think it's it's a good policy just to, kind of go in and clean house every once in a while, whether it be a mobile device or a computer itself. Go in. When I did the update for Java, actually just yesterday on my computers at home, I went back through and checked what programs were on there, took a good hard look at the ones I really needed to be there and removed those, which kind of leads to the fact that I guess some old Javas can stick around if you're not careful about it. Is that right?
That's what I've heard, yep.
Yeah, they tend to stick around there forever. The older versions, especially 5 and some of the early versions of 6, when a new version installed, it wouldn't uninstall the previous version. Now, at least when you apply 7U13, it uninstalls 7U11. But and there have been some reports, and we've had some conflicting experiences with it, that one of the recent versions of 7 was supposed to go back and uninstall 6, but I know, Brian, it didn't work for you. You still had an old version of 6 on there.
In fact, there were even 2 installations of the old version of 6. So, I think that's, there was, I think, some good reasons for doing that, particularly early in the Java lifecycle, and I'm not sure to what extent that's still around. I'm not really a Java developer. Maybe you folks have some other insights into it, but there certainly were applications that required a certain version of Java. That is, I think there were some, as the tool set was evolving, there wasn't necessarily full backward compatibility through all of the life cycle. So there certainly were applications that required an older version, and there may have been a patching cycle that was still in place for some of those. Eventually they get to be kind of stale, and you might not be needing it for an application any longer. So they really need to be deliberately, you go in and install those older ones.
Yeah, and that's the biggest reason why you'll still see older versions of Java in enterprise environments, is they still have some application that works under Java 6 that doesn't work under Java 7.
Right.
There's a lot of that out there.
Absolutely. So I encourage, it's encouraging to see these updates. As Matt pointed out, 50 is quite a lot of security updates to include, particularly in a particular release. I think they work on sort of loosely a quarterly cycle for the updates. It might be just a little bit less than quarterly for these updates. As Matt had pointed out, this update was pushed out a little bit earlier than it was originally scheduled to be, which is sort of a good sign. I'd like to see a little bit more of a more aggressive patching cycle associated with this particular platform. It is awfully popular, and the significance or the frequency of zero-day exploits seems to be on the rise across the board. So not just particularly for Java, but it seems like they're sort of steering in that direction. So it seems to make sense to get a little more aggressive about that patching activity. So with that, Java obviously is not the only software with flaws in it and things that need to be patched. And it looks like even protocols can have some problems. Is that right, Jim?
Yeah. This time it's TLS and DTLS. We talked, there were some SSL vulnerabilities last year. Well, the lucky one today is called Lucky 13, and it's an attack that was outlined in a paper by a couple of folks, one of the University of London branches. It's a PhD student and his advisor, and they outlined in a paper that was released yesterday a number of attacks that they found against TLS and DTLS. TLS is Transport Layer Security, and DTLS is Transport Layer Security or something like that. But they're related protocols. And what this allowed them to do was recover authentication cookies, for example, from encrypted HTTPS sessions. It's completely different from the Beast attack from last year. and the crime attack from last year, which were also protocol attacks. But this particular one, with somewhere on the order of being able to sniff 2 to the 13th to 2 to the 23rd sessions that had the same plain text in the same place in the session, they by observing timing, they could actually decrypt the contents of the packet. To get that many sessions, to capture that many sessions, requires some effort, probably requires being on the same LAN segment as the machine that you're trying to capture from. So it's not yet probably a practical attack that somebody could launch remotely, but if they use similar things to the Beast attack, which had JavaScript continually launching multiple sessions, they were to do something like that, they might be able to improve the efficiency of the attack. Microsoft claims that their implementation of TLS is not susceptible to this. The open source versions, OpenSSL, GNU TLS, and Opera all released updates yesterday or today that address this. NSS, which is the package that Firefox and Chrome use, they expect to release that patch in the next couple of days. To be completely protected from it, you really need to handle both ends of the connection. And if you're using, a shared library version of it, you apply the patch, you still need to probably reboot the system or at least close all of the existing instances because they'll continue to use the old version of the shared library until you restart it. So that is one issue there. I borrowed this slide from this diagram from the Ars Technica write-up about the attack. But basically what happens is the TLS inserts a header and a sequence number in front of the payload, does some calculations on it, and then applies that MAC, the end of the packet that it then encrypts and sends over the network. So by taking advantage of either the padding or being able to detect where the header and the sequence number are, that's how they can go about starting to work your way back and decrypt it piece by piece. So it's kind of a more technical than we have time to go into a lot of detail here. But if you have a web server, you probably want to make sure that you update to the latest OpenSSL or GNU TLS or whatever your web server is using. And as the browsers get updated to include the newer versions, you're going to want to update those too. As I said, Opera came out with the patch yesterday. Firefox and Chrome, they're expecting the patches in the next day or two, so be on the lookout for those.
Do you know much about the nature of the patch, Jim? Like, is there something fundamental that they're changing about to protect against this?
Yeah, well, what they're doing is they're trying to fudge the fact that because I looked at the changelog or the bug discussion for the NSS to try to get the details of what it was they were fixing. And what they found was that the issue was a divide instruction that took varying lengths of time depending on the contents of the packet there. So what they were doing is they're fudging it. They're putting some meaningless instructions there, and one of the issues is they hope in the future the optimizer doesn't optimize away their protection against this. But they're trying to adjust for the fact that it took varying amounts of time dependent on the data. So they're trying to make it more uniform amount of time it takes for regardless of packet.
That's very interesting. You know, that's a little different than I expected. It's certainly a reasonable way to do this sort of thing. That is, these timing sort of attacks can, as you pointed out here, taking on the order of 2 to the 13th sessions to be able to develop a reasonable capability to do decryption. And that was actually the research case. It was quite a bit larger, and some of the other examples are more real lifetime types of examples that might exist. But I think more and more these types of things are going to become important to pay attention to as a part of security. That is, timing factors as well as controls. That is, how many sessions are you willing to accept from a particular source? And there are already things where so many checks tries on a password, you're supposed to get locked out of the system. But even just otherwise normal-looking sessions, there probably need to be more controls than exist today. And I think we're going to see more and more cases where that's going to be necessary.
Well, one of the issues that played into this was one of the previous fixes that they had put into the TLS was to shut down the session and make you renegotiate a new one in certain error conditions. And so this attack actually plays off that behavior by forcing more, by being able to force more connections. You have more of them to, more sessions to try to use in this particular attack.
Still trying to fathom the thought of having 2 to the 13th sessions as a basis to be able to figure out what's going on there. It's a pretty big number, but then again, all these numbers seem to get smaller over time as the computing power and network capabilities increase. So we shouldn't rule that out as a possibility. Interesting article there. I think that's, again, more and more of these kinds of things we're going to see in the future. That is, the level of sophistication isn't necessarily a criteria for considering it safe. That is, once somebody implements the capability to exploit that, you don't necessarily need to know the technologies behind it. It becomes just a matter of executing it and having an opportunity to execute it. So something to keep in mind as well.
Well, and the issue isn't just the protocol, it's the implementation of the protocol. Because there was some other paper recently that was proving how secure TLS was. Well, the protocol itself is fine. It's the implementation that's got these timing features to it that in this case introduced the issue. Anyway.
Brian, if I may, there are a few interesting talks that I came across recently on the subject of timing attacks from the 28th and 27th Chaos Communications Congress. I believe one of them is called Time is Not on Your Side. So if anybody's interested in getting a really good examination of timing attacks, that's what I'd recommend you look into.
Good. Thanks, Matt. And if you have some links on that, maybe we can share that in the program as well. And so, Jim, apparently we can't decide whether it's Windows or Android malware in this particular example. Is that right?
Yeah. The other thing I wanted to mention today was an article I saw from the folks at Kaspersky, I guess on Friday, that they had discovered a couple of applications that were initially in the official Google Play Store. They've since been removed. And what they did, they claimed to be Android apps that would clean up your phone, your Android device, and it had this nice little side effect that what it did legitimately on the Android device was it would just restart all of the apps that were running on your device, and it would put up on the screen that it had cleaned and restarted all of these apps. In the meantime, it would go out and download a couple of files and put them in the root of the SD card in your Android device. It would put an autorun.inf file, a folder.ico file, and then an executable called svchosts.exe. And then it would wait for you to plug your phone into your Windows box to sync it up. And as soon as you did that, if you had autorun enabled, which hopefully most modern systems don't anymore, but if it had autorun enabled, the Windows device would see this autorun.inf file in this USB device, and it would go and execute, and it would fire up this svchosts.exe, which if you looked in Task Manager, maybe you wouldn't notice the trailing S on there, and you'd think it was one of the system devices. Now, the interesting thing is that the malware that actually ran on the Windows box didn't do much of interest. What it would do is it would start recording using default audio input device. So if you had a microphone, on the laptop, you're going to have one, but you may not have one on your desktop. But if you have a default recording device configured on the system, it would start recording the audio at random intervals for small periods of time, and then upload these to some FTP server that the bad guys controlled. I'm not sure what the whole purpose of that was. I would have expected something, try to steal banking credentials or something, but no, this one was turning on your microphone and recording audio.
Yeah, I kind of wonder if this was really a test of their ability to deploy malware in this manner. And, it's clearly a case where this wasn't an accidental situation. I mean, a lot of times when malware propagates through a USB device, it's, there's some accidentalness associated with that is, picked it up from another source of media. It was sort of the natural propagation of the malware. But this is clearly a case where the app was pulling from from the network and installing that function onto the SD card, right?
Yes.
Yeah. So I'm kind of wondering if this was really just sort of a test run to see if this was a successful way of deploying things, because clearly, as you sort of pointed out, in some of these financial attacks, what they're trying to do is get both the Windows device and the mobile device infected, so that it can intercept the out-of-band authentication messages that are used by some financial organizations to help provide sort of a two-factor authentication function. And by doing that, it still allows these financial fraudsters to go out and perform fraudulent transactions using stealing the user's credentials in effect.
Yeah, the Android malware did have the capability that it didn't seem to make much use of sending SMS messages, enabling Wi-Fi, sending off the IMEI of the phone, uploading the entire contents of the SD card. It could have done a lot more. It appears not to have used much of these capabilities, but it had the permissions to do it, and the capabilities were there. That
certainly smells like a test run to me. So I expect we're going to see some things like this, maybe variants on this theme going forward a little bit more. And ironically, I think it was it just last week we were talking about compromised cameras and the ability to monitor different people's computers. I can't remember if it was last week or the week before. It all blurs together, but this is sort of another example. They could have taken control of the webcam on these computers as well. Okay, with that, thanks, Jim. That was, again, another interesting twist on the evolution of malware here. let's take a quick look at the internet weather for the week, and I'm going to characterize the past week as relatively quiet. We haven't had any real significant events take place, but I'll point out a few that I thought were kind of interesting here. First one is scam probes on port 65,500 TCP. This port isn't really directly associated with any particular applications. It is loosely associated with the Apple XSAN file system. That's a storage area network interface for Mac OS. And that port is used in a dynamic sense. So I'm not sure if that's really what they were targeting in this case. There's a slight possibility that's what they were looking for, perhaps scanning around to see if there are internet accessible storage area networks that might be, possible to get to. The probing that we're seeing here, it's relatively sporadic. I actually decided to show 90 days back of activity here. We're seeing what I would call the increase in interest over the last week or so, but we have seen spikes in activity previously, and then dating back into around the beginning of December, we did see sort of a somewhat regular scanning activity on this particular port. Now, most of the recent probes have been from a single source in China, and I also took a look at other activity associated with that source, and it is associated with other probing activity. I don't think there's any strong relationship in terms of application, but there was also probing on port 22 TCP and port 1433 TCP, oftentimes associated with password guessing activity. So that kind of points perhaps more toward, looking for open file systems or something, or perhaps some other application that I wasn't able to find. The next one here is scam probes on port 88 TCP. Port 88 is associated with Kerberos. That is basically a single sign-on authentication system, showing 30 days of data here. And what we're seeing is over the last week or so, we saw what appears to be a single source of activity. It's correct that, in fact, it was a single source. And you see that there's basically a spike and then sort of trailing off activity that could be related to the address pattern that they were using in the scanning activity. And this port is used by many operating systems, Windows, Mac OS, Linux, and others, all of which either have the capability or use Kerberos for single sign-on capabilities. And again, a single source in China doing the scanning activity not associated with the one on the previous port.
That's also frequently used as an alternate HTTP port too, which would be a possibility. But
that is a possibility as well, yeah. Thanks, John. Next one here is, and we reported on this, I think, perhaps last week or the week before, scan probes on port 5631 TCP. This is PC Anywhere. It's one of the earlier applications that had come out that allowed remote access to PCs. Since then, I think remote desktop protocol has sort of taken as a preference, but perhaps there's still more PC Anywhere installations out there. Looking back 30 days, it's very sporadic sort of activity. I wouldn't describe what we're observing recently as any increase in activity. It's just there's sporadic activity that kicks off alerts here. And it's originating from a few addresses. A couple of them are basically U.S.-based addresses. They're hosting providers, perhaps computers that have been compromised or used for that scanning activity. There's also at least one source in China, so just a handful of sources. And at least one of those addresses, one of the U.S.-based addresses, has been associated with scanning also on port 3389. So port 3389 being remote desktop protocol that may also be a target of this, the actors that are behind this. Looking at the top 10 most probed ports, no surprises here. We see the most prominent ones we're actually seeing, and we're going to take a little closer look at this a little bit later, port 16464. That's not actually probing activity, it's peer-to-peer activity associated with the zero access botnet. Also associated with that same activity is this port 16471 and port 16465. So we're going to take a little bit of a closer look at zero access in a moment here. What other ports that are being probed 445 TCP, 23 TCP, 22 TCP, 1433, and 3389, all of which we typically see. And oh, by the way, 5900 TCP as well, which is virtual desktop. Excuse me, virtual. Help me out here, guys.
Virtual network computer.
Thank you very much.
VNC.
And next one here is the most sources probing. Again, very similar. These 16,000 UDP ports. So again, we're going to take a quick look at those. And no other surprises here. We've already talked about 23 TCP and 3389 TCP that also show up in this graph. So with that, let's take a quick look at the zero-access botnet activity. And what we're looking at here are several of the ports that are used in the peer-to-peer communications associated with zero-access botnet. And we're looking at 180 days of activity. So you can see that there are some basically ups and downs associated with this. And the reason I wanted to bring this up today is that beginning around I would say near the end of December here, we saw sort of an uptick in the number of sources. And by the way, we're looking at the number of sources that are active on these particular ports. We saw an uptick, maybe 15% or so, in the number of sources that were specifically on port 16464 UDP. And then over the last couple of weeks here, starting around the 15th of January, and since then we've seen a clear increase in the number of sources that are active on port 16464 UDP. That's a fairly strong indicator that there's been perhaps a campaign to propagate this malware more so. And recall, perhaps you've seen in previous programs that we're already familiar, zero-access botnet is typically associated with click fraud activities. So it's using end-user computers to generate clicks so that it can rack up advertising revenue for the actors that are behind this activity. So that botnet is not diminishing by any stretch of the imagination. In fact, it's exhibiting some growth recently. So with that, that's our program for today. I'd like to thank you for joining us. And if you'd like to get in touch with us, you can contact us through email at threattrack@lists.att.com. The video program is available on the AT&T Tech channel at att.com/threattrack. It's also available on YouTube, and an audio version is available through iTunes. Thanks once again for joining us today. We'll be back next week with a new episode, and until then, keep your network safe.